Today we are on the worksheet ionic compounds, and we will be learning how to draw Lewis structures for ionic compounds. So we'll start off actually with number 2, which is magnesium and chlorine. When you want to draw the Lewis structures for these, what you need to do is you need to look at the periodic table, and we'll take a look at the group that they are in. So magnesium, Mg, is in group 2. You can see right here. So it's going to have 2 valence electrons. And chlorine is in group 7. So it's going to have 7 valence electrons. So if you were going to draw a magnesium, it would go with 2 dots. And then if you drew a chlorine, it would have 7 dots. So recall what elements are tending to do is to either gain or lose electrons to have 8 valence electrons in their outer shell. You can see that magnesium is going to tend to lose 2, but chlorine is only going to tend to gain 1. So if this magnesium gives up an electron to that chlorine, you're going to need another chlorine to gain the other electron that the magnesium is going to lose. So if you drew that here and you gave that electron away, now what's going to happen is the magnesium is going to be a charge of +2 after it loses 2 electrons, and each chlorine is going to be a charge of -1. So if you drew your final copy of this, it would look something like this. You would draw an Mg, you would draw 2 Cls. Each Cl would have 8 valence electrons. Magnesium would have none drawn. And then you would draw the charges in of +2, -1, and -1. And then to write the formula for this, you would just write MgCl2. To write the name of this, you would just call it magnesium. The metal will keep its name. And the nonmetal will change to an IDE ending of chloride. And lastly, you're going to try to find the electronegativity difference. You're going to reference this chart in your packet, and you're going to compare the magnesium and chlorine electronegativities. So here is magnesium 1.3. Here's chlorine 3.0. You would just take 3.0 minus 1.3. So 3.0, minus 1.3 equals 1.7. You do not double the chlorine, even though there's 2 of them. You just take 1 chlorine minus 1 magnesium, and you take the difference of that, and that is going to be a 1.7 difference. And you'll see that 1.7 is going to be a fairly large difference between a metal and a non-metal, and that's why the chlorine will actually take the electron from the magnesium as opposed to sharing. So if we take a look at one more example, we could actually find a shortcut for doing this. If we take the next example of potassium and oxygen. So you could just right off the bat figure out the charges. So you know that K and O on the periodic table, K is going to form a charge of +1. O is going to form a charge of -2. So you know right away that that has to be a K2O. And then that can help you to write the final copy very easily. You're going to have a K here. You're going to have a K here. You're going to have an O here. You know that O has 6 valence electrons on its own. Each K only has 1 valence electron, as you know. So it's easy to see that the K is going to give 1 electron there, and the other K is going to give 1 electron there. And that's going to be a -2. That's going to be a +1. That's going to be a +1. And then you could figure out the name and the electronegativity difference the way we did before.